Fountain Powerboats has a well-earned reputation for building some of the fastest performance boats in the world. Among the records the company's boats hold are the world's fastest V-bottom at over 135 miles an hour, the fastest single, twin, and triple engine V-bottom, and the Catamaran Formula One record at 155 miles an hour. To find out what makes Fountain Powerboats so fast, I visited the company's plant in Washington, North Carolina, and asked founder and chief executive officer Reggie Fountain to show me the secrets of what he calls his positive lift hull.
The step we have in the boat right here, combined with the step of the boat right here, allows the water to come across and aerate itself, float the boat up on aerated water. Air has less drag than does water. Aerodynamic drag is, of course, less than hydrodynamic drag. That increases the speed of the boat and the smoothness of the ride when you inject the air into the water. As the water pours over the top of these steps in the boat, and the air comes around here and mixes with it, so you're riding on a smoother, softer, less resistant surface, making the boat run faster and smoother. We have right down in this area a pad, the area from here to the keel, and also right here from this area to the keel on each side, which is at slightly less degree of dead rise than the rest of the bottom. This allows you to have maximum lift at the keel, but still with enough dead rise that the boat gives a much smoother ride than a boat that just relies totally on lifting strakes alone. Because this is, again, at the keel at the lowest point, lifting the boat up out of the water, again, reducing hydrodynamic drag, running the boat through the top of the waves instead of down through them, gives you a faster, smoother ride. Now let's go back to the back of the boat and look at some areas back here. This is the business end of the boat that we're going to now. In the business end of the boat, you'll also see an example again of our pad, but you also see a setback transom. That's basically where the bottom ends here. The engines are bolted in, or the drives and engines are bolted into this transom, which is recessed some or removed some 15 inches or 14 inches behind the bottom on this particular boat. This leverages the boat, allows these drives to pick the nose up and carry the boat over the water better, thereby reducing hydrodynamic drag and increasing the performance of the boat and helping you trim the boat. That is, how the bow of the boat reacts up and down and how the stern of the boat reacts up and down. This also allows you, with the setback transom, a higher X dimension where your drives are set up higher and you can still take off without excessive cavitation, because when the water comes across this step, or setback transom, I'd call it, it allows the water to flow up and come up over these propellers and to give you the kind of hookup with your propellers you need to have a takeoff. If the transom was also the end of the bottom here, then there would not be enough time for the water to come up and get a good bite on these props, so you'd slip when taken off or cavitate. Well, you can raise the motors up and have a higher X dimension and more speed once you get going and the water becomes harder, because the propellers will hook up at high speed. The problem is how they hook up at low speed, and you need to get the water over them for that. So at low speed, that water, again, with the bottom removed up here, flows up high and comes right across here and gives you a whole blade bite. When you're going faster, then the water starts straightening out behind the back of the boat because you pass over it so fast and it runs right through here, and this prop spinning up on top of the water with only the bottom half of it in the water, and you remove all this part of the gear case out of the water. And for example, this boat right here, V-bottom, that we just built for a customer, we went out yesterday and first running, it ran 108 miles an hour.
I also asked Reggie to explain how different settings of the drives and trim tabs affect his boat's performance.
Well, these drives, as you see them here, these Merc Cruiser stern drives trim out and they trim in. In would be with the torpedo coming up under the boat, pushing the stern of the boat up and the nose of the boat over for initial takeoff. And also, if there's big waves, to keep the stern down, you'll trim these drives in, lifting the stern of the boat, lowering the nose of the boat. Same thing with the tabs. They trim the boat here just like the drives do. When these tabs drop down, the water comes off the bottom of the boat, hits these tabs, forces them up. They are bolted to the boat, so when it forces them up, it in effect pushes the bow over again. So when these drop down and the drives come in, you can get up on a plane quicker or plow through big waves quicker because you've got the bow pushing through the water. Now, everything changes when you want to go faster and get up on top of the water and run over the water. So then you start trimming these drives out, sort of like these are now, maybe not quite this far out. Lift these tabs up to relieve all the pressure on the transom that's pushing it up, and it lets the water flow through easy. Lets the transom drop down in the water, thereby raising the bow of the boat when the stern of the boat drops because these tabs went up. And when these drives come up, that lifts the bow of the boat and relieves you of hydrodynamic drag and makes the boat go faster.
Making boats go faster is what Reggie Fountain is all about. And you can see proof that his positive lift hull works every time a Fountain powerboat goes zooming by.
That Reggie sounds like quite a character.
He's one of the originals, Ann, and he builds a fine boat. One of his recent customers is former President George Bush.
Really? You know, when we come back, we're going to take you to the Mediterranean.